Hello, my dear students. Welcome back to my YouTube channel. As you know that we had completed the first chapter of 11th, right? That is motion in 1D or the kinematics. Now, from today onwards, we will be doing projectile motion or also known as motion in a plane. This chapter will take, I guess, 4 to 5 lectures to get completed. Then we will start NLM, right? So this particular week we are going to discuss this motion in a plane, and then next week we are going to deal with NLM, then WPE, circular motion. Like these things, we are going to complete our whole syllabus. Done. And also I am going to start some numerical series for 12th also, some PYQ series, some NCRT series as well. And one more series that I am going to start, that is the English series. The lectures will be in English language, that is Hindi language, okay? In coming days. As you all know that I don't have any association with any institute right now. So I have plenty of time, so I will try it right in a very good manner with you. So let us continue now. I hope this thing is very clear to you. This board and my voice is very audible to you. Okay. So let's start now. Motion in a plane. Very first lecture now. So let us start. Okay. So we will be starting from what is projectile motion? What is projectile motion? If you know that from the first lecture of kinematics, we discuss about various types of motion, 1D motion, 2D motion, and 3D motion. In 2D motion, the example that we wrote now, that was projectile motion, and one was circular motion. Now, what is projectile motion? Projectile simply means, if let us suppose we are having velocity in this direction or in different direction, and we are having acceleration. If we are having some angle theta between acceleration and between velocity, so the path that we are going to discuss with, and this path is known as projectile path, projectile motion. Then simply velocity and acceleration, velocity and acceleration, these are collinear, not on the same line. So this type of motion is known as projectile motion. Now we have types of projectile motion. I will change the pen now. We have types of it, right? We have two types of projectile motion, two types. First type known as oblique projectile. Second one is known as horizontal projectile. Oblique projectile is also known as ground to ground projectile. And horizontal is also known as height to ground. That is, look now, if this particular thing is ground and we are projecting something like this, right? Like this. So it will go in this manner and comes back to the earth, right? So this is my ground to ground projectile. Suppose the motion of the ball. Second one, if look now, here we are having a building. This is my building, a tower. So from this particular height, I am throwing something. It will go in this manner. This known as high to ground, and this one is known as horizontal projection. This is known as oblique projection. I guess this one is very, very, very easy to you. Done? Now, the very first thing that we will be discussing here, that is displacement. Look, one thing, 2D, what is 2D? We can break down 2D into 1D and plus 1D. Suppose we are dealing with XY plane. Suppose, no, I will just do it x-axis motion plus y-axis motion. How, sir? Look, if my particle is going in this way, this is final position of my particle, this is initial position of my particle. So what is displacement? Displacement in x-axis. This will be xf, final x minus initial x. If particle is going in this way, final position of particle in y-axis, initial position in y-axis. So what is displacement in y-axis? You were right. Position final in y-axis minus position initial in y-axis. You can write like this. But if we are dealing with 2D motion, so how we will deal it? So I will write S2D. It will be x2 minus x1 I-axis. I will add it with y2 minus y1 in j-axis. This one known as displacement in 2D. These two are displacement in 1D. So 1D give us 2D. Done? If you need to write velocity also, look, we know V is equals to U plus AT. If we are writing for X, I will write Vx, Ux, Ax, Tx. If Y, so I will write Vy plus, equals to Uy plus Ay multiplied by T. But what is total velocity? My total velocity will be Vx, that is in I direction, plus Vy, that is in y direction. In the same way, what is acceleration? Sir, net acceleration is acceleration in x direction plus acceleration in y direction. It simply indicates you need to write everything in 2D motion. Then you need to write in 1D, then summation of these two things, you will get 2D motion. Okay. So the very first thing that we need to discuss here, that is ground to ground projection. Ground to ground projection. Ground to ground. Look now. This is my x-axis. This one is my y-axis. Done? X-axis, y-axis. Now we are projecting a particle. We just did a project a particle in this way. With some angle theta. What will happen? The projectile will go in this way. You can see the projectile motion. The particle will go in this way and comes back to the ground. Okay. the velocity by which we are projecting particle is known as u, and we know that this u get divided into two parts. This u get is divided into two parts, one in x-axis, this thing known as u in x-axis, which is also equals to u cos theta. This one is in y-axis, so I will write here uy means u sin theta. Everything that is downwards is negative. Everything that is upwards is known as positive. Okay, this point is known as highest point. So this point is known as highest point, h max. This one is known as h max. And at this particular point, we only have one velocity factor, that is u cos theta. No u sin theta. Okay. Done now? And the velocity by which we are projecting something, it will comes down with the same velocity. That means the velocity, this one will be same. It will be u. And this is also theta or minus theta. So this could be u cos theta. This thing never changes. I will tell you the reason why. And this one known as u cos theta. U sin theta. Or you can write here minus j cap. Acceleration in x-axis is 0. But acceleration in y-axis is acceleration due to gravity, that is minus g. Particle goes from, look, particle goes from this point up to this point. This thing is known as, so this thing is known as, look, from this point to this point. This point. This thing is known as range. This one is known as range. Distance between point of projection to the point of strike is known as what? A range. Done? This is my total figure that you need to remember. Okay. Look here. If let us suppose at time t my particle is here. At any time t my particle is here with velocity v. So this velocity I will make two components. Angle, let us suppose alpha. So this thing will be always same. It is u cos theta or ux or vx, and this will be vy. And if I just join these 2 points, this one is displacement. This distance is y, displacement in y, and this displacement is in x. Now look, first of all I will write for x direction. Done. Is there any acceleration in x direction? No, sir. What is vx? Acceleration in x. It will be always ux. It will be always u cos theta. If no acceleration present, velocity is constant, u cos theta. Done? Okay. For y direction. What is ay? Sir, ay is minus g. Okay. What is vy? Sir, vy is not constant, it will be variable. Vy will be variable. And what will be the value of it? Look now. We know one equation, v equals to u plus at. So for this one I will write vx ux plus v equals u plus at, a into t. A is 0, so my vx is equals to u cos theta, always constant. And if vector, so it will be in I direction. Now vy equals to ui u plus at, a y, then t. Vy vectors. Uy, what is uy? Is it u sine theta? Yes, sir. It will be u sine theta minus gt. The whole thing will be in j direction. So is my net velocity. Net velocity is vx in I direction plus second one is j direction. What is vx? I can write u cos theta I cap plus u sin theta minus gt j cap, this velocity. The only thing that you need to remember from this slide up to now is only this equation. Only this equation that you need to remember. What is the magnitude of this velocity? Sir, it is very simple. It will be vx square plus vy square root. Okay. What is tan alpha? Tan alpha, this angle alpha, it would be vy by vx. What is vy? It will be u sine theta minus gt upon by u cos theta. This thing you need also to remember. Done, no? Okay, now displacement. I will change the color for displacement now. Displacement x, it will be xi direction or delta x into y into j. So what is displacement? I guess we know now s equals to ut plus 1/2 of at square. Yes, sir, we know it. Look, for x-axis, I will write, look beta. For x-axis, sx, uxt 1/2 of axt square. No x, it will be 0. So sx will be ux. Ux is u cos theta multiplied by t. Equation first, let us suppose. And sy, it will be uyt plus 1/2 of ayt square. U sin theta multiplied with t minus 1/2 of gt square. Second equation. Now place these values in my previous equation. So can I write here? It is u cos theta multiplied by t into I cap plus u 1 by 2, 1 second, beta. 1 second. So it will be plus u sin theta multiplied with t minus 1/2 of gt square into j cap. Look, from the whole slide, what you need to remember now? What you need to remember? This equation, 1. This equation, 2. This equation. From the whole slide, only these three equations you need to remember. Only these three equations. Okay, from the whole thing that I just explained here, what you need to remember or what you need to memorize, that only these three things. V u cos theta into I cap plus u sin theta minus gt j cap, and tan alpha vy by vx u sin theta minus gt by u cos theta, or s equals to u cos theta into t I cap plus u sin theta minus 1 by 2 gt square into j cap. Only this dabba thing is you need to remember, nothing more than that. Why, sir? Look, I am going to give you the question now. Now question, right? Look now. My question is like, initial velocity is given as 50 meters per second. And theta is given as 37 degrees. After 2 seconds, After 2 seconds, what you need to find out? First thing, what is position vector? What is position vector? What is position vector? Sir, what is position vector? Look now. Position vector is x direction, x vector. It is delta xi or xi plus delta yj or yj. Then, if you need to elaborate the whole equation, how you need to write it? So I can write S. Position vector is u cos theta. Why, sir? Look, because we know that S equals to ut plus 1/2 of at square. If you don't need one, so you can write u cos theta t. Done. If you need to write in vector, so plus u sin theta multiplied with t minus 1/2 of gt square into j cap. Okay. So I can write u. What is u? U is 50. Then we are having cos 37 degree. It is multiplied with 2. And I cap plus u. U is 50. Then sin 37 degree multiplied with 2 minus 1/2 of into g is 10. It will be 2 square into j cap. 50 is 50, cos 37 is 4 by 5 multiplied with 2. Here is I cap plus 50 sin 37 is 3 by 5 multiplied with 2 minus 1/2 of into 10 into 2 to the 4 into j cap. 5 ones are 5, 5 10s are 50. It is 40 80. It will be 80 I cap plus 5 ones are 5, 5 10s are 50, 30 60 60. So I can write here 60 minus 2 ones are 2, 2 5s are 10, 5 for 20, 20 j cap. So I can write it is 80 I cap plus 40 j cap. This is my position vector in meters. Okay. Second part. Part B. This is not clear, this one color. Part B. Part B is velocity vector. Velocity vector. So what is velocity vector? Sir, velocity vector means v vector, which is vxi cap plus vyj cap, or v equals to u plus at. So v equals to u cos theta I cap plus u sin theta minus gt into j cap. What is u cos theta? U cos theta, it will be 40. So I can write 40 I cap plus u sin theta. U sin theta is 60. It is 60 minus g is 10. It is 20. Done? 1 second now. 330, 20, 60, 60, 20. It is 20 j cap. Done? No, it is not 60. It is not 60. It is 30 only, right? 30 only. Look now. Look now, beta. So what is V here? Is it 40 I cap plus 10 j cap? If you need, it is magnitude, no? Simple. What? 40 square plus 10 square, then a root. 4 1600 plus 100, that means 1700. It will be 1700. I can add 10 root 17 meter per second. Third part, what is alpha? What is alpha? We know that tan alpha is equals to Vy by Vx. Vy is u sine theta minus gt divided by u cos theta. U sine theta is 30 minus gt, it is 20. U cos theta is 40. So my answer is 10 by 40. So my tan alpha came out to be, it is 1 by 4. So alpha is equals to tan inverse 1 by 4. Inverse 1 by 4. A good numerical, right? Done? Okay, next numerical. Okay, look now. Question number second, it states that initial velocity is 50 meters per second. Angle of projection is equals to 60 degree. Done. Alpha is equals to 30 degree. Now I need to time in which the body goes from 60 to 30. That time I need to get. How to get it now? Sir, tan alpha, I guess tan alpha is nothing Vy by Vx. What is Vy? Is it u sine theta minus gt? What is Vx? Is it u cos theta? Yes, sir. Tan alpha is tan 30 degree. U sine theta, u is 50. It is sine 60 degree. Minus g into t, yes, whole divided by u. U is how much? It is 50, and here we are having cos 60 degree. Tan 30 degree is 1 by root 3. They were having 50 multiplied by sine 60 is under root 3 by 2 minus 10t. Whole divided by 50 cos 60 is 1 by 2. So I can write 1 by root 3. I can take 10 common. So we are having here 5 multiplied by root 3 by 2 minus t. Whole divided by, I can take 50 into 1 by 2. 1 0 1 0 cancel out. I can write here, it is 2.5 something, right? So 1 second. 1 by root 3 equals to 5 root 3 minus 2t whole divided by 2 whole divided by 5 by 2. 2 to cancel out. So I have here 5 divided by root 3 equals to 5 root 3 minus 2t. So 2t is equals to 5 root 3 minus 5 by root 3. So 2t equals to 5 root 3 into root 3, that will be 5 into 3 minus 5 whole divided by root 3. 2t equals to 5 3s are fearless wise. So we have, it is 15 minus 5 divided by root 3. So 2t is equals to, it is 10 divided by root 3. 2 1s are 2, 2 5s are 10. So therefore time is equals to 5 divided by root 3 seconds. So the particle takes 5 divided by root 3 seconds to get from 60 to 30 degree, right? So if you need to make the projection of the particle, so if particle goes like from in this way, if here is 60 degree, so somewhere here will be 30 degree, right? It will be 30 degree. The timing to get from 1 to 2 position, na, that is 5 divided by root 3 seconds. Done? Okay, one more numerical. We projectile a ball with projection of speed is u, angle is theta. First thing, initial velocity vector. We have to find out initial velocity vector. Initial velocity vector would be u cos theta I cap plus u sin theta j cap. This will be my initial velocity vector. Second one, final, that means striking on the ground, final velocity vector. Final velocity vector. If you know the first diagram, there I show na v final will be u cos theta never gets changed plus u sin theta, but that one is in minus direction, minus j cap. Done. Third one, velocity vector at top. Velocity vector at top. I told you that at the topmost point only one velocity is present, that means u cos theta only. U cos theta I cap. No u sin theta. Fourth point, that means change in velocity from point of projection to the point of strike. So I can write velocity final minus velocity initial. Done. I can write it is u cos theta I cap minus u sin theta j cap minus u cos theta I cap minus u sin theta j cap. Done. So as you can see that cos was get cancelled out. So my change in velocity came out to be minus 2 times u sin theta j cap. If you need to write only it is magnitude, right? So magnitude way I can write it as a 2v sin theta only. To v sin theta only. Okay. Now, most important numerical. I can write here important numerical. Okay. It states that, look, we threw something into the air. Okay. And it comes back. We know it comes back. Suppose x-axis, y-axis. We threw something in this way. Here it is going in this direction. Suppose here it is coming in this direction. Now, if we just get it like this now, so the angle is 90 degree. That means initial velocity is perpendicular to final velocity. Now I need to calculate the timings in which my initial velocity vector or my final velocity vector becomes perpendicular to my initial velocity vector. Okay. Time after which velocity of my particle becomes perpendicular to the initial velocity vector. Okay. Firstly, what is initial velocity? Initial velocity, is it u cos theta I cap plus u sin theta j cap? Is it like this? Yes, sir. What is final velocity vector? We know that v equals to u plus at. So I can write it as only u cos theta I cap, then u sin theta minus gt j cap. One should be perpendicular to the another. Therefore, from vectors, if two vectors are perpendicular to each other, so their dot product must be equals to 0. Do the dot product of these two, u cos theta, u cos theta. Can I write here u square cos square theta plus u square sin square theta? Done. Minus u sine theta multiplied by gt came out to be 0. I can take here u square common. Internally we are left with cos square theta plus sin square theta minus u sine theta gt equals to 0. Now the whole thing becomes 1. So u square multiplied by 1 minus u sine theta gt equals to 0. So 1 u cancel out. So I can write u minus sine theta gt equals to 0. So I can write my sine theta gt is equals to u. So t came out to be u divided by g sine theta. U equals to g sine theta. So this is the timing is in which my final velocity becomes perpendicular to my initial velocity. Done? But one condition is there. This is only valid when my theta is more than or equals to 45 degree. This thing is only valid if my theta is more or equals to 45 degree. If my theta is less than 45 degree, so my particle will strike the ground before becoming perpendicular to the initial velocity. My particle will strike, if my theta is less than 45 degree, then my particle will strike the ground before coming perpendicular to my initial velocity vector. Done? One more thing, look now here. If you can zoom now, if we can zoom it, is there any option to zoom it? There is no option to get it. Look now, this particular point, right? Look, I will take it here. This is my initial velocity u with angle theta. These are perpendicular, so this will become 90 minus theta. This is v. So this is u cos theta. And this will be u cos 90 minus theta. Both are equal, right? So I can write u cos theta equals to v cos 90 minus theta. So u cos theta equals to v sin 90 minus theta is cos 90 minus theta is sin theta. So I can write sin theta. So v is equals to u cos theta by sin theta. V equals to u cot theta. Value of your final velocity. Okay. Look now. Next numerical. Numerical, I will write the whole language of numerical. A projectile has thrown from ground. It strikes perpendicular to wall. Find speed of projectile when it hits the wall. That simply means this is my projection xy. Here is my wall. this is angle 60 degree now. So my projection would be like this. This is my projection. Okay, I need to find out this velocity with which it strikes the wall. This is my wall. It's my angle theta, 45 degree. Let us suppose it's my u velocity. What we know that, sir, one thing that we know from the previous things. So look now, this is my velocity v. So if this is my 60 degree and look, it is striking perpendicular, so this is my 90 degree, so this will be my 30 degree. Done. If this is my 30, so this will be my 30 degree. So this side will be my v cos 30 degree, and this side will be my u cos 45 degree. So both will be same. So we know that u cos 45 degree, it will be equals to v cos 30 degree. U cos 45 is root 2. V cos 60 is root 3 by 2. So v is equals to 2 divided by root 2 multiplied by root 3 into u. So v equals to root 2 divided by root 3 into u. Or you can write it v equals to under root of 2 by 3 into u. This is my answer. Okay. Next numerical. Look now. So my numerical is like this. Look. This is my numerical. Okay. Here we projected a particle with velocity 20 meters per second. This one. And this angle is 60 degree. And it needs to hit this target. Target, let us suppose C. But it hits due to gravity. It is target at here. Let us suppose at B. And this height is h. We need to calculate this height h. This height h. How we can do it? Look, if gravity is 0, if my gravity is 0, I can write height is h1, this height is h2. If my gravity is 0, so what I can write, h is equals to h equals ut 1 half of g. G is 0, so I can write h1 equals to uy multiplied with t. Done. If there is gravity h2, gravity is not equal to 0 now, So I can write here uy multiplied with t minus 1 half of gt square. So what is h? H is equals to h1 minus h2. So h equals to h1. H1 is uyt minus uyt plus 1 half of gt square. Cancel out. So my height gets out to be 1 by 2 gt square. This is my value of my height. Done. This is how you can find out the height difference between the target and the missing point. Done. If let us suppose this is 5 meter, just get my h. Look, is this u cos theta? Yes, sir. So speed equals to distance by time. So time is distance is 5 meter, speed is u cos theta. Done. T. 5 is 5, u is 20, and cos 60 is 1 by 2. It came out to be 5 by 10. So my t came out to be 0.5 second. So right, I can write h equals to 1 by 2 into 10 into 0.5 multiplied by 0.5. So h came out to be 2 ones are 2, 2 5s are 10. It is 5 into 5 into 5 in 10 to power minus 2. So h came out to be 125 10 to power minus 2. My answer is 1.25 meter. This is my height, 1.25 meter. Done. Very easy. Easy numericals. Look now. Now we have some important parameters. Some important parameters. Important parameters. Important parameters. First one is time of flight. First one is time of flight. Time of flight, that is t. It was 2u by g. So I can write 2u. U is u sine theta here. Divided by g. Because sine theta is responsible for timings and cos theta is responsible for dragging. So if you need t max, if you need maximum time, so sine theta is 1. So my answer is 2u by g only. Second part, height. Height is h only. It was u square divided by 2g. So here it is u square sine square theta divided by 2g. What is h max? Highest my height. U square is u square, sine square theta is 1, 2g. What is my range? Horizontal range. Horizontal range, it would be speed into time. Speed is u cos theta multiplied with t. So look here, I can write u cos theta into t. What is t? T is 2u sine theta by g. So here I can write 2 u square cos theta sine theta by g. Or I can write it as a u square 2 sine theta cos theta by g. And this thing is sine 2 theta. So I can write here range is equals to u square sine 2 theta divided by g. So if we have to find out range maximum, look, so I can have to be sine 2 theta is maximum, that is 1, that is sine 90 degree. So 2 theta is 90, so theta is 45 degree. That means if the projection angle is 45 degree, you will get your range as maximum. You will get range as maximum range. Now let us do some numericals based on these two topics only these topics. And the topics are, look beta, my velocity is given as 6 I cap plus 8 j cap. First, find time of flight. Time of flight. So what is time of flight? T. I guess T is equals to, is it 2u sine theta by g? Yes, sir. Look, my standard formula is u cos theta I cap plus u sine theta j cap. So 2 u sine theta is 8. I can write 2 into 8 divided by 10. It is 1.6 second. Second is my height. How to find now height? What is height beta h? Is it u square sine square theta divided by 2g? So I can write u sine theta, both are square. I will just square both of them. So divided by 2g. U sine square theta, is it 8? Is it 64 divided by 20? Is it 3.2 meter? Third, range. How to find range now? Is it range u cos theta multiplied with time t? U cos theta is 6 and time is 1.6. 36, 9.6 meter. Final velocity. Final velocity. Is it u cos theta I cap minus u sine theta into j cap? U cos theta is 6 I cap minus 8 j cap. Yes or no? These are my answers. Easy or super easy? Super easy, no? Okay, second type of numericals. Body is projected with initial velocity 50 meters per second and theta is given as 37 degree. First part, what is time? So what is time? Flight time? Is it 2u sine theta by g? Yes, sir. 2 is 2, u is 50, sine 37 is 3 by 5 whole divided by 10. 0, 0 cancel out, 5, 5 cancel out, 3 to the 6, is it 6 second? Second part, height. Is it u square sine square theta divided by 2g? So u is 50, so I can write 50 multiplied with 50. Sine square theta will be 3 by 5 multiplied by 3 by 5 whole divided by 2 into 10. 1 0, 1 0 cancel out. 1 5, 1 5, 1 5, 1 5. So my answer is 10 into 3 3 are 9, 9 divided by 2. Is it 90 by 2? Is it 45? Is it 45 meters, right? Third part, that is range. Range is u cos theta multiplied with t. U is 50 cos 35 multiplied with t. What is t? T is 6. So 5 ones are 5, 5 ones are 5. It is 10 into 4 into 6. It is 40 into 6. 240 meters. 240 meters. Okay. One amazing point. Let us suppose if theta is 45 degree. If theta is 45 degrees, so my range came out to be a range max, R max. Okay. What is range here? What is range formula? Is it u cos theta into t? For basics, no? Yes. What is range formula? Is it u cos theta into? Is it 2u sin theta by g? Yes, sir. Range. Is it u square sin 2 theta divided by g? Is it so? Yes. What is R max then? R max is it u square divided by g only? Equation first. Equation first. Done? Okay. What is height now? Height? What is height? Is it u square sin square theta divided by 2g? Place theta is 45 degree. Then let us see, right? So height equals to u square divided by g sin square, it is 1 by root 2 square whole divided by 2 h u square by g into 1 by 4. So h, look, what is u square by g? Is it R max? So I can write h equals to R max by 4. That simply means if we are throwing something into the air with the angle of 45 degree from the ground, it will reach to its maximum range, but the maximum height, this h, this height is equals to R max by 4. That means this thing means it is R max 2, this is R max 2. Done? So coordinates of this point is x comma y. What is x? R max by 2. It is R max by 4. Two things. Most important thing that you will learn. Okay? I guess for today we are discussing more than enough. So now in second lecture we will be discussing something regarding numericals. Firstly we will start numericals. Then we will do a lot of things, right? I hope you enjoy today's session. If you have any doubts or if you want to ask me anything, you are most welcome. Below the description part you will find the Telegram link. In Telegram channel you will find my notes, the books and all this stuff related to your subject. So thank you, bye, good night, take care, beta. Thank you, beta. Bye, good night, take care, bye.